Good day, everybody. I'd like to give you a quick introduction of what we are doing in the medical space with MamBase, our high-performance universal database. It is a clear example of how you can mix historical data and knowledge together to arrive at a situation where you can build better decision models with better results. MamBase has said we believe is a next-generation database technology for game-changing solutions. And we hope we can explain that today. So first of all, MamBase is a multi-model database, and let me try to explain what that means. So we have relational data traditionally. So for example, on the cardio, we have the heartbeat data, the inspection data. On the skin, we have the color data, etc., all in relational databases. Then on the other hand, we also have unstructured documents, medical news, publications, regulations, images of x-rays, etc. And then there is the knowledge data, where we basically store in our database how the unstructured documents, the relational data, and what we see with respect to our patient, how that all links together. So what are the complaints? Which complaints are related to what diseases? What temperature belongs with that? What is the health condition? But also, are there time series? Are there events in over time that are correlated together and have a significant meaning? All of that we can store in one single database platform. Now, in addition to that, we have developed a methodology based on the ancient principle of DIKW, or data science, information science, knowledge science, and wisdom, making better decisions. Data science, we all know of recognizing trends and patterns in historical data, anomalies, etc. But alone that doesn't help us very much. We need to have information science where we know how to visualize that data or how to visualize trends and patterns. But also knowledge. What knowledge is captured in what the data science is telling us and what the information science is telling us. Excuse me. And then last but not least, how do we design the decision models that takes advantage of the knowledge, the information, and the data that we have? Now, a little bit further about knowledge. What does it actually mean? Let's take this classical example. Yeah, we have a person, Albert, he lives in Paris, he likes comedy, and then we have the data around the theaters, A, B, and C, where C is in Lyon, and A and C are showing a movie of Mr. Bean, and the theater B is showing a movie of Maigret. Maigret is, of course, a thriller. And you have the so-called supergraphs where you go back from the thriller all the way to Albert, or from the comedy all the way to Albert. This is a typical example of how to store knowledge in conjunction to relational data. What is also quite relevant in this respect is that once you store the knowledge, you can represent that knowledge by rules and extract them by rules, including the statistical facts like the probability, the frequency, or the exceptions, or the averages, or the special cases, for example. Now, let's look at a use case, an emergency room, using a knowledge base based on MamBase. First of all, when we start looking at this, we look at this from a perspective of designing smart solutions. So re-engineering mission-critical applications to smart solutions. Now, first of all, the emergency room, you need to, in order to build an app for an emergency room, you need to build a smart database first, which means you need to store all the knowledge, all the facts, all the relations between data regarding health. So we need to build a knowledge base inside MamBase with all the known diseases, and then with the different access paths. So an access path for symptoms, an access path for measurements, and an access path for complaints. And the design, the decision models on what to do next. So once we have seen that the temperature has a 38-degree fever, what does he need to do next? Then we store not only the knowledge data, but also the test results. And as a general knowledge base, so patient independent, but also for each patient. And then there are two options. We either do it within our solution or we connect to an existing patient system and gather the data from there. Now let's look at how to easily register everything that is done. So on the right here you see a simple iPad application where you simply have to touch and enter the data that is relevant to this individual patient. You have different treatment rooms that you are connected to, and you can easily update everything as soon as an event comes by. Yeah, so each patient gets its own storyboard, and there are status reporting and tests that have been done, tests that are yet to be done, etc. Yeah, the result of all of this is that the trainees, so the junior doctors, learn much faster on the job, and you have less errors and delays due to forgotten checks, as this system will remind you of the checks that still need to be done or should be scheduled to be done. Yeah, and in addition to that, what is also key is that there is a very easy and swift handover in the emergency room between doctors, consultants, or specialists. So a little closer look is this screen is all touch and go. Yeah, you can easily touch the different body parts if you want to enter something about that. You can touch the amnesia, the visual examination, the auscultation, the palpitation, the laboratory test, and the instrumental examinations. Everything is easily and with one touch and go to be entered. Now let's have a short demo of the database that's behind all of this. Yeah, and then we're of course talking about MamBase, and let's look at the demo database that we created. So first of all, this looks all very easy and simple. We have created here the respiratory system. I can attach the labels. What is important to notice is the speed of this database. Yeah, I just clicked on the labels, and within a second it retrieves all the labels from all the different bullets that are in this database. But I can also add the heart environment, so the cardiovascular system and the gastrointestinal system. And as you see, it becomes quite easily a mess. But then, of course, I want to see what is typical for the health in a certain person. And so here I have the connections between all the green circled results of examinations that you can see. Yeah, and I can easily pull this one to the side so that you can see the different environments. And again, note the speed. Yeah, this database is a high performance environment that allows you to in real time find all the relevant data regardless of how many results it is going to present. So I can easily remove the labels, and then I can add other environments, like the skin, the urinary system, etc. And again, they're all connected to the central health point through the circular, green circled around the dots. And also you can add certain diseases. So for example, if I switch off a number of these, let's switch off the health and the norm, but we have asthma defined. So what are the characteristics of asthma? So if you have the system here, you have the different checks. Let me switch on the labels again so that you can quickly see the different labels. So if he has bronchial character of breathing, or it's a hard breathing, then those are the typical signs of asthma. And so you have like a small whistle, or you have a dry cough, or well, you can see it's all in there. The database is not finished yet. This is still under development, and we develop it in conjunction with a university and a medical faculty of a university, of course, because we don't have all this expertise. But it shows you that you can have the speed to retrieve the knowledge, the speed to check everything, and to categorize any type of disease in the system, and including automatic updating with new medical publications if and when needed. So this basically concludes our discussion. My name is, like I said, Mark van den Akker. This is my telephone number. You can reach me at mark@supergraph.nl. For further inquiries, please let me know if you have any other questions. Thank you. Bye-bye.